Welcome back. As you may know, in JavaScript, we have a native error constructor function. If I go error like this in my console, well, that's a function that we have, a constructor function. Remember, capital letters. That means it's a constructor function. And I can create new instances of these errors by doing new error. And in here, passing a message like oopsie. If I run this, look at that. I get an error with oopsie. Now, the error instance, which is what we created with the new keyword, it doesn't actually do anything. As you see over here, I get something printed out, but it's not really an error. What we need to do instead is to throw an error. When we start throwing errors, that's when things get interesting. In JavaScript, we have the throw keyword. And when we throw something, well, your script that we're currently running stops executing. Or at least stops executing it unless you're handling this throw somehow, which we'll go over. So when we do something like throw new error, I now get a proper error. What has happened underneath the hood is that the error gets thrown and says, all right, stop the program, handle the error somehow, we have an error in our program. And this throw statement is used to define our errors. So during runtime, when we run our JavaScript, when a throw statement is encountered by the program, the execution of the current function will stop and control will be passed to the next part of the call stack. But before we get into that and how to handle these things, let's just go a little bit more over throw. You see, I can throw anything in JavaScript. I can throw a string if I wanted to. There you go. I can throw a Boolean value if I wanted to. Nothing too crazy. I can even actually throw the error constructor function, which is, well, the function. And then obviously our regular way of throwing an error, an instance of the error. As you can see, when we throw something, it stops the execution of our program. So that if I do throw new error and right after it do 4 plus 3, we're never even going to get there because our program gets stopped and says, hey, we have a problem. Let's stop whatever we're doing and throw. Get outside of the program. Now, this error property has 3 built-in properties for us to use. Let me show you. If I go const my error and do a new error here, call it once again, oopsie. Now when I do my error, you see that I have the error right over here, but I have 3 properties. One is the actual name of the error, which is error. We also have the message property of the error, which is, as you can see, oopsie. And the third, last one, and a very important one, is the stack trace, which can be accessed through the stack property. And you see over here that that is my stack trace. It's just a string, but it shows me where the error happened. In this case, it happened inside of an anonymous function, which is the main global execution context. For example, if I do function A, and inside of this function, I do a B variable that has new error. This one is going to say what? And we finally return B and close the function. Well, when I run A now, I see that I get a stack trace. I get the first item on the stack, which is the global anonymous global execution context. And then I have the A function that was called. So it's actually showing me what's happening on our call stack. We have the global execution context and then the A function. And the error was thrown inside of A while A was on top of the global execution context. So as you can see here, if we had another function inside of here that was getting called, let's call it C, then the error would show up as C, A, then the anonymous global execution context. And I can access this, even though it prints it out for me, by doing the stack. And as you can see down here, we have our error stack, which shows us where we were in our call stack when the error happened. This way, we see what's responsible for causing that error. It's almost like seeing your history in action. Now, here's the thing. JavaScript has many built-in constructors for errors, specifically standard ones that you may have seen before. You see, we have the generic error, but there's also new syntax error, which you may have seen when you get an error when your JavaScript syntax is off. For example, if I do something like this, I get a syntax error, unexpected token, because, well, JavaScript doesn't understand this. There's a syntax issue here. We also have something like a new reference error, which, once again, you may have seen if I do, let's say, a variable that I haven't defined, I'll get a reference error. And as you can see here, it automatically throws and has the throw keyword added upon it as soon as we have an error. The throw statement is used to generate our exceptions, our errors. But here's the thing. So far, errors are useful, but what if we wanted to handle them inside of our programs? For example, during our program, when a throw statement is encountered, an error is thrown, our current function is going to stop. And sometimes we might want to catch that error instead of, well, stopping the entire program. So how do we handle them in JavaScript? Well, in JavaScript, this is pretty much the system for errors. This is our call stack. And as soon as an error happens on the call stack, we go to the execution context underneath us and say, hey, is there a catch for us? Is there something handling this error? Nope. Okay, then I'm going to keep going. Is there a catch? Is this error handled anywhere in this part of the execution context? No. And if all the way through the call stack, there's nothing handling it, well, we're going to get this onError function that runs inside of the browser that gives us that red text that we see. In Node.js, instead of the onError, we have the process.on onCut exception. So the runtime handles the errors if nothing in our program catches this. If the exception always just zooms straight down to the bottom of the stack, well, it's not very useful. Our programs just end. The power in the errors, and what we're going to learn about, is in the fact that you can create these little hurdles, these little stops along the call stack to catch these exceptions. Because once you've caught these exceptions, you can do something interesting to address the problem so that your program doesn't stop running. Instead, you handle these errors so that your program keeps running. So how do we create these obstacles, these hurdles? How do we catch an error in JavaScript? For that, I'll see you in the next video.